All right, this is the Algebra 1 Unit 4 Lesson 5 video over slope and rate of change. So this is a really important concept in algebra. When we're looking at a linear function or a linear relationship, the idea of the rate of change is a really, really important concept. So when we say slope or rate of change, we are talking about the changes of the x and y values in relation to each other. So what it means is, like, if I were to look at the points of a function, I graph all these xy points. We already learned that there is something consistent happening along these points. The rate of change is consistent. The amount the x and y changes stays the same in a linear function. So when we talk about slope or rate of change, we are looking specifically at describing that as a number. In other words, how much is it changing down in relationship to how much it's going across? And you can see that that amount or that relationship is staying the same. So this line is going down and over the same amount each time. A way of talking about that would be to call that the change in y oops, sorry about that, a little messy. Change in y divided by the change in x. So this is the way that we think about this. We look at the function and we decide how much is the y changing from one point to the next, how much is the x changing from one point to the next, and what is that number that represents that ratio or relationship. And you also will see it written with this symbol, call that delta y over delta x. That is the same as saying change. So we're looking at the change in the y versus the change in the x. So there are four main overarching categories that your slope can be. Okay, so we're going to talk about this kind of as a separate issue. So I'm going to draw four graphs for those four relationships. Imagine each of these is an xy graph, and we might have one like that, one like this, one like this, and one like this. So our slopes are going to fall into one of these four categories. And these categories are as follows. The first one you see here is what we call a positive slope. The value of that is going to be a positive number because the graph is increasing from left to right as we move across. That means the next one is going to be negative. So this is an example of a negative slope. The line is going down from left to right. The last two kind of represent unique cases. This is what we call a slope of 0, meaning it isn't actually increasing at all. It's just staying flat. There is no up or down change. And then lastly, we have what we call undefined. So slopes where the line goes straight up and down vertically is called an undefined slope. So you definitely need to know this information, but we're going to get more into the details, and we're going to learn, how do I determine the slope of lines? And so in general, we're going to do two different ways. We're going to look at the mathematical way, the way to calculate it using numbers, and we're also going to look at the graphical method. So we're going to start with graphing. So let me jump over to another drawing here, and we're just going to go through some examples. Okay, so let me pick one to start with. Let's start with this guy. So with this one, we have 2 points graphed here on the coordinate plane. And remember, when we talk about slope, we're talking about the change. Get a little thicker of a drawing tool there. Change in y divided by the change in x. Another way of talking about that you'll see is the rise over the run. In other words, how much is the graph going up or down versus how much is it going across? So in this example, I can see that my graph is going from one point to the next, from this point to this other point. It's going to go up 2. This is up 2. See? 1, 2. That's up 2 or plus 2. And it's going to go over 3 units. 1, 2, 3. 3 units. So this 2 is my rise, and the run is my 3. And that number, that's it. That is the slope of this line. It goes up 2 units for every 3 units that it goes over. And that's how you find the slope graphically. So let's look at another example about this one. Again, I want to find the rise over the run. I can see that the graph goes from, I can find any point. There's actually a lot of places where this crosses at a specific point, but really this is going to be pretty easy because it goes up 1, over 1, up 1, over 1. So it's 1 over 1. So the graph, the slope of this is 1 over 1, which simplifies to be just a value of 1. Your answer doesn't have to be a fraction. In this case, 1 over 1 simplified to be just 1. And so this one has a slope of 1. So we get another one. We already did that one. Sorry about that. There we go. All right, let's look at this guy. Well, this has the coordinates on there, but that's okay. We'll still do it. So we want to go from, we want to find the rise over run here. Looking at these, I can see that this graph goes up 4 units, 1, 2, 3, 4, and then it goes 1, 2 units over. So the rise is 4 and the run is 2, which 4 divided by 2 is 2, which makes that the answer for my slope. Pretty straightforward. Now let's look at some negative examples. So here we have an example where we have negatives. We want to find, again, the rise over the run. So we look at this and we see that to go from one point to the next, it goes down and then over. It's going to go down 3 units. That's going to be a minus 3. So down means minus because we know that negative slopes have that basic way of going down. And it's going to go over 4. Again, 1, 2, 3 down. 1, 2, 3, 4 over. So it's going to be negative 3 over 4, and that's the slope of this line here. Okay, I have one more example, and then we'll do graphic method. This one's a little hard to see. Let's zoom in a little bit. So again, we're looking at rise over run. This looks like it's going to go down 2 units. Over, let's see. So it's going to be down 2, over 1, 2, 3, 4, 5, 6, over 6. So down 2 over 6, that fraction can be reduced to be negative 1 over 3, which is the final answer, negative 1/3. So hopefully those examples are helpful. There are other places on the web where you can find just simple examples of how to find the slope. But now I want to talk about the equation. So this right here is the equation for calculating the slope of a line. So what I'm going to do is I'm actually going to come back over here and we're going to do one of these examples again. So let me grab a screen grab of one of our examples here. Let's do this one we've already done. We already know the answer to this one. But let's give ourselves some room to work. So we'll copy that. Let's come back over here. And let's do some work over here. All right. So we know we want to find the slope. And the formula, and I'll write it again here, is m equals, m is the letter we use for slope, y2 minus y1 divided by x2 minus x1. So where do these x and y numbers come from? X and y numbers come from the points on the graph. So 0, 3, we'll call that point 1. That's going to be x1, y1. And then 2, 7 is going to be x2, y2. So those are where we're getting those values from. So let's take these numbers and put them in the formula where they belong. We see that y2 is 7. It's coming from right here. So 7 minus y1 is 3. x2 is 2. Minus 0 is y1, minus 0. 7 minus 3 is 4. 2 minus 0 is 2. 4 divided by 2 means that m is equal to 2, which is the exact answer we got earlier. So when given 2 points, even if you don't have a visual, you need to plug those values in. So let's look at one where we don't get an image. Okay. So let's say they said I have 2 points. They say find the slope. And they'll give us 2 points. So it gives a point. Let's say we have 4, 5, and 8, -1. All right, so we want to find the slope between these two lines. All right, so first of all, we know this is going to be my x1, y1 value. It's going to be my x2, y2 value. And so when I go do my formula, oops, you're going to need to have that formula in front of you for a lot of this last part of the pack. Okay, so y2 is -1, minus y2 is 5, x2 is 8, x1 is 4. See what we get. -1 minus 5 is -6. 8 minus 4 is 4. And then when we can reduce that, we get -3/2. And that is the answer for that one. So that's pretty much it. I mean, you just have to be careful with your negatives, plugging things in the right place, and then when you do the work, kind of making sure you're ready to simplify that fraction. So let's do at least one more example here. All right. Let's say I have 3 and -2. Eight. Actually, I'm going to change that. I'm sorry about that. Let's do 8 and 3. All right. So let's look at what happens here. So we have our values. I'll go ahead and label them for this one as well. X1, Y1, Y1, X2, Y2. So when we go plug in our formula, Y2 minus Y1, X2 minus X1. Well, that's going to be 8. Nope, it's going to be 3 minus -2. That's a little weird. Keep track of your negatives. We have y2 is 3 minus y1, which is -2. So minus -2. We'll deal with that in a second. X2 is 8. X1 is 3. The bottom works out pretty easily. That's going to be 5. Let me just erase it real quick. Give myself a little more space here. That's going to be 5. 3 minus -2. Well, 3 minus -2 is actually going to make 3 plus 2, so that's also going to make 5. And then that fraction reduces to a 1, and that's the answer there. So let me just jump over to the lesson so you can see what kind of things you're going to be doing. Obviously, there's going to be some vocab here. 1, 2, and 3 is all vocab, so read the lesson and make sure you answer those vocab questions. 4, 5, 6, 7, 8, 9, all is doing what we just got done doing, which is calculating the slope with 2 points. So just plug everything into that formula. And then on number 10 and through 11, 12, 13, you are looking at graphs and finding the slope. You do not need to do the mathematical way. However, look out for lines that have one of our special slopes. Just to remind you of that. Remember, we do have some, we have positive, we have 0 and undefined that are kind of our special cases for slope. So just be aware of those. So when you're answering those might be the answer. But with some of these, you're just going to need to do the counting like I showed you on the example. Number 12, number 13, all that. Starting with number 14, they're asking for rate of change. This is another way of saying slope. So look here, you could just simply make these the points for x1 and y1, x2 and y2, and do the slope formula with these points. So choose any two. You could use any two of the numbers in the table as your 2 points, x and y points, right? So each of these could be done that way. Oops. Same thing with number 15. Pick any 2 points, calculate the slope. 16, I'll just go ahead and get you started on this one. Again, pick any 2 points. So like for day 3, that could be written down as 3, 15.75, and that could be one of your points. Then we could do day 6. Day 6, 19.5. And so those could be my x1, y1, x2, y2 points. Number 17, answer a question about the graph. It's asking about the different slopes for those different areas of the graph. So it's like, what's the slope of this section of the graph versus one of the others? Pretty straightforward on that. And then number 18, again, find the rate of change. So you just need to use these as points. I would say use this as your x and this is your y. So you would have a point here. Right here would be a point. Right here would be a point. And then you could use those as the x and y for your slope calculation. All right, that's it for lesson 5. Reach out to me if you have any questions. And I will post our last lesson video here on Wednesday.